Hi there, in this video we're going to continue section 1.3, factoring common factors, and I'm going to start with the greatest common factor, abbreviated GCF. So we'll do an example with numbers first and some variables. So the greatest common factor is, so for numbers is what factors do they have in common, but then the greatest means you want to take out the largest. So notice that 12, 18, and 30, these are all even number, so 2 is a factor, but 2 is not the largest. All of these have a 6 in common as well. And so 6 ends up being the largest common factor. So the GCF here will be 6. For the second one, we want to look at the GCF of both the coefficients and the variable term. So for the coefficients 12, 28, and negative 16, what they have in common is a 4. So the GCF will be 4 for the coefficients, and then x cubed, x squared, and x to the 7th. The greatest common factor, right? X cubed means x times x times x, x squared is x times x, and x to the 7th is x multiplied by itself 7 times. So the greatest thing that they have in common will be the x squared. So our GCF will be 4x squared. Now when we're trying to factor an expression, you might see something that says factor completely. And say, for example, I want to factor the expression 3x to the 4th minus 6x cubed plus 9x squared. So in order to factor that, I want to take out the greatest common factor, the GCF. So first we have to identify it. So our GCF in this case, again, look at the coefficients. So you have 3, 6, and 9. So the GCF is going to have a 3 in it. And then x to the 4th, x cubed, and x squared. The one you can take out is the x squared. So this is our GCF. So now when we factor, we take out the GCF. So I'm going to have 3x squared on the side in parentheses. Notice that I have a trinomial in here, so I should still have a trinomial inside the parentheses. And so when I take out the 3x squared, what do I multiply 3x squared by to get 3x to the 4th? So that's going to be x squared. Right, now when you multiply these, notice you're going to have 3 x squared times x squared. When you multiply same bases, you add exponents. 2 plus 2 is 4. And same thing here, minus. What do you multiply 3 by to get negative 6? So it will be minus 2. And then to get an x cubed, I need an x. X squared times x, we add the exponents, so it'll give me a 3. Plus, and then to get 9x squared, I just need the 3. So when you take out a common factor, that doesn't change how many terms you have. You should still have a trinomial, and you're just going to have the GCF on the outside. So let's try something that looks a little different. So if I have something like z plus 1 cubed minus 7 z plus 1. Now the instructions here say to factor. So resist the urge to try to multiply these out. So because we want to factor, so we need to find the GCF. The greatest common factor in this case is the quantity z plus 1. So we're going to take that out. And when we take z plus 1 out, what are we left with? Well, we're left with z plus 1 squared minus 7. And at this point, you can continue to simplify that. So it'll be z plus 1. And now I can square out the z plus 1 square. And remember, z plus 1 square means z plus 1 times itself. So don't forget about those middle terms. So we're going to have z squared plus 2z plus 1, and we have the minus 7. And now we can combine like terms. So my final answer will be z plus 1 times z squared plus 2z, and 1 minus 7 is minus 6. Let's try a couple more examples. So if I have something like negative 35x to the 4th y squared plus 14xy cubed plus 21x y to the 4th. So same thing, what is going to be your greatest common factor? Again, look at the coefficients. So I have negative 35, 14, and 21. So it looks like 7. Because the leading term is negative, we want to take the negative out as well. So it'll be minus 7. Anytime your leading coefficient is negative, you want to take that negative out. From the x's, we have x to the fourth, x and x. So the largest we can take out is the x. Is what they all have in common, right? This is the largest thing in common. From the y's, we have y squared, y cubed, and y to the fourth. The largest we can take out that all have in common is the y squared. So this will be our GCF. So we take out the GCF, and what are we left with? And don't worry about whether I'm using parentheses or brackets. It's just a grouping term. So it doesn't matter if you use parentheses or brackets. So let's see. I took out the minus 7 to get a negative 35. I need a 5, right? Negative 7 times 5 is negative 35. I took out a single x. So to make it x to the fourth, I need x cubed. And we did take out the entire y squared, so I don't need it there. We did take out a negative, so that to get a plus, I need a negative, right? Negative times a negative will give me plus 14. Negative 7 times what? Will be minus 2. I did take out the x, so that one is gone. And from the y cubes, we took out 2 of them. So we're just left with 1y, or sorry, y to the first. And then we took out the negative, so then that's a negative, and 7 times what is 21, so that will be 3. We took out the x, so I don't write it, and took out a y square, so to make it y to the fourth, we need a y square. And there are no like terms there, and there's nothing else to do, so that's as far as we can go. Let's try, what about x? Let's do something with negative exponents. So if I have 2x to the minus 1 half times x plus 1 plus 4x to the positive 1 half times x plus 1 square. So how do I factor this? Again, you're being asked to factor, so try to resist the urge to multiply things in. We want to factor, so we want to identify the GCF. So the GCF in this case is, notice that every time we take something out from a variable, we take out the one with the smallest exponent. So here, between x to the minus 1 half and x to the positive 1 half, which one is smallest? Well, negative 1 half. So we're going to take, and from the coefficients, a 2. So we're going to take out the x to the negative 1 half. And from x plus 1, that's x plus 1 to the first, and x plus 1 squared, we're going to take out an x plus 1 to the first. So that's our GCF. So when we factor, I'm going to have my GCF on the outside. And now we need to do the factoring part. So the idea with factoring is when you put something back in, so what do you multiply x to the negative 1 half by to get x to negative 1 half? Well, that's going to be a 1. So the 2 and the x to the minus 1 are gone. And this whole thing is also gone. So I'm just left with the 1 there. Plus, we took out the 2, but I have a 4 there. So 2 times 2 is 4. And now, what exponent does the x need? So when I multiply it by x to the minus 1 half, I get a positive 1 half. Remember, when you multiply the same bases, we add exponents. So another way you can think of it is, excuse me, what do you add to negative 1 half to get a positive 1 half? And that's going to be 1. X to the 1. And then we took out the x plus 1 to the first. And to make it x plus 1 squared, we need another x plus 1 to the first. So this will be our answer. Now I can simplify it. So I'm going to have 1 plus, this is just 2x, so now you can distribute it, plus 2x squared plus 2x. And if you're asked to write it with positive exponents, then this will become, and I'm going to write the inside in descending order there, and it will be over x to the 1 half, because remember, a negative exponent means it really belongs on the bottom. So if you're unsure on this part, right, what we did here is essentially I want to know if I have x to the negative 1/2, what do I multiply, what exponent do I need so that I get x to the positive 1/2. So that's what I was saying, that what do you have to add to negative 1/2 to get a positive 1/2.